Hey everyone, welcome to part 2 of my reverse engineering short series of Windows Snipping Tool. And if you haven't seen part 1, please watch it because we'll continue on from where we left off. To kind of like recap, well, first off, I'm working in a VM, as you can see. And to recap, I created my folder here. And in the first part, what we created, we allowed multiple versions of a snipping tool to run at the same time. So for instance, if you start a default snipping tool and you make a snip, and let's say decide to run another version of a snipping tool, let's say if you want to make another snip, well, it won't let you do it. Well, with my modification, if you run the snipping tool, and I usually pin it to taskbar, but for some reason this doesn't let me. But if you run two versions of a snipping tool, as you can see, it actually lets you create several snapshots without the need to save it and then restart it. Now for some reason it doesn't let me pin it to a taskbar. Let me try real quick. I think I have to drag it in here. Okay, yeah, so now it should work. So basically, you see, I can start as many instances as I want. So the first part was dedicated to this kind of work. Now what we did, we modified the binary code of this app to allow this to happen. Now the second part of this reverse engineering tutorial was supposed to be very simple. So let me show you. So if I make a snip of a snipping tool, as you can see, this part at the bottom is kind of like a waste of space. It's just telling us that, hey, the snipping tool is moving away, try to use something else. So just as an example of how you can modify a GUI of a certain app, I was thinking, well, let me just remove this thing, right? So it's kind of like, useless, and, definitely we're kind of like prolonging the lifespan of this tool. So obviously there's no need for these buttons. If you think about this, what is the best way to remove this? So let me use Paint, I guess, to kind of show you. So if you look at the snipping tool, it's basically just a window, right? In the bottom of the window has all this unnecessary stuff. So my thinking was, what if I just, remove this part? Or in a more like traditional way, what if I take, this window and just shrink it, right? Just change the height from this to this. It should be very simple. And that was my thinking, right? It's kind of like just the window height, pretty much, If we look at how exactly Windows Snipping Tool is made, and I'm using Detected Easy, so if I drag into it, and as you can see, it's compiled as a C++ project. It's 64-bit GUI, and most of the C and C++ code, kind of like old day code, and all the GUI stuff, was actually made with what is known as Win32 resources and dialogs. It's kind of like an old school and kind of easy way of making GUI. And that is why I thought that the Windows Snipping Tool, the main window, is also a Win32 dialog. Just to show how you can quickly change it without even resorting to going into coding. Let me try this with my own tool. I'm kind of like, for a second, forget about snipping tool, and I'll experiment with my WER setup, or Windows Error Reporting setup. So if you open it up, And by the way, we can do the same thing with the detected easy. As you can see, it's also C, C++, 32-bit GUI, and also it's MFC. Now, if you remember, MFC was like really old school library, GUI library, and the presence of MFC definitely tells you that the app internally uses Win32 resources and dialogues in this case. So if you look at this app, this outer window is a dialog. And in this case, we can easily change its height without even going into coding. So let me show you what I mean. If we open it with Resource Hacker, all of these things are Win32 resources. And then if we go into dialog and find our main window, like this one, right? So on the right, it kind of shows you, the Resource Hacker shows you the layout of the window. And again, if you remember, let me just make sure I can see everything at the same time. If you start the actual app, this on the left is exactly what you see here on the right, except on the right, it's kind of like shows you the layout and stuff of the app. Okay, so having that, what we can do, we can simply modify one of these values. For instance, instead of 419, we can set it 319, and we can compile. And as you can see on the right, we literally cut the height of the app. So, and then if we save it, so what we did, we kind of created the app, the Resource Hacker created the original, you know, the one that kind of looks normal. And then we have our shortened version. Now, obviously, this is stupid because you can't use the app since, you know, you can't resize it and the bottom of it is missing. But you get the point. So this was my idea to do with the snipping tool. If we can just cut the height and remove all the stuff. Again, we don't really have to remove the buttons and the code for them, but because they are not visible on the screen, the users won't hit it and they won't be present. So before I go any further, let me undo my damage here because I still need my tool here. Make sure it runs. Okay. Okay, guys, so how do you approach this? So my idea was to do exact same thing. So I dragged this thing into Resource Hacker, and the thinking was like, hey, that would be very simple, you know, reverse engineering tutorial kind of to show it first. Well, little did I know, this took much, much longer to actually fix. Let me show you why. So as you can see, the original executable doesn't have a dialog. What it has is, well, Microsoft is called MUI, which is multi-user interface, I think. So the actual resources or localizable resources are located inside of this MUI file. It's kind of like a DLL without any code. It's just like a resource-only DLL. And that's specific for English language, as you can tell by English US over here. Okay, well, this thing has a dialog, so I was really happy. And I was like, okay, let me find it. Well, it has this dialog. And if you start the GUI app, the snipping tool, let's see, you can kind of see this being options, right? And then it has this dialog. But what it's lacking is the main window. So I was like, interesting. Well, what happens is that the author of, well, any app doesn't have to use a certain technique, in this case, dialog resource. They can create this stuff manually. Now, to check what you can do, you can run my WinID tool. And if you remember, you have to point mouse to controls, and then in the window it actually shows you what the thing is. As you can see, most of the controls inside are, you know, Win32 controls that are common controls that are known that way. But the main window is a special class. If you look over here where I'm pointing at the mouse, kind of small, sorry for that, the class is Microsoft Windows Snipper Tool. And that is a problem. It basically tells me, not necessarily, but it tells me that this dialog is actually not a dialog. It's just a window that they create manually through code. Because if you run, you see, if you run my worst setup, again, if you look at the class line in WinID, when I mouse over, it tells me that this is a dialog box. Again, this is not always the case, but in this case, you can clearly see that my worst setup is dialog, but this thing is not. So what they're doing internally is that they create all of these buttons and windows on the fly with code. And that basically means that we have to open this sucker in IDA or in any native debugger and actually see what is happening there. Well, guys, let's do it. So I guess there's no way to avoid code today. Sorry, although probably most of you come here because of code. Let's see. I opened the IDA before, that's why it's giving me that warning. Again, we see that it's a 64-bit PE file, nothing special. Let's go over here. Now, the good thing is, if you remember from part 1, because this is Microsoft tool, it actually comes with server symbols. I mean, symbols on the server or the PDB file. So make sure to click yes and have it downloaded. And at this point, I believe we will lose most of our breakpoints. Let me let IDA finish loading here. Yep. So the first thing I do, I usually put a breakpoint at WinMain so we can actually step through it. And let me add a breakpoint window. Let's see, breakpoint list. Okay, so WinMain. Okay, well, at this point, we need to, roll up our sleeves and actually look through code and see how we will tackle this. Okay, guys, before I start, going into disassembly and stepping through the actual code, let me kind of review this real quick. So when you run a kind of old school Win32 app, how is the window created? Now, in this case, you will need to have some programming knowledge, and basically the way you create Win32 window is by using CreateWindow, not Windows, but WindowXW, sometimes A, but new ways it's W. And this is the function that has all these parameters that creates the window. So now keep in mind that this is a very low level function that creates all kinds of windows. So what we need to actually check that the class of this window coincides with what we have for our main window. Now let me start with WinID and I kind of explain it again. So let me remove this thing out of the way. So when I mouse over, as you can see, again, I'm checking over here when I'm pointing with the mouse inside the WinID window. Now, when I mouse over its main window, it gives me Microsoft Windows Snipper Toolbar. So this is the class that I'm interested in. But then if I look here, the class is Toolbar Window 32, then we get static, then we get another static, then we get a button, another button, so all of this stuff. But there will be quite a few calls to create window X, and what we need to locate specific one for this class. So to capture it, I'm going to hit Shift, and Shift is a part of WinID, and then if this button on the top left where it says 1, if I click it, I can copy this class. Let's see if I can do it in one shot. And what I usually do, let me create a text file, and in this case we will be doing removal of bottom banner. And what I usually do with Notepad, I just add all my nodes here. So this is the class that I will need to look for. So let me maximize so you guys can see it. Okay. Well, so let's kind of like get into code and try to catch invocation of this CreateWindowX. So let me start with the debugging with IDA. And when the breakpoint hits here in WinMain, as you can see here, we need to locate where exactly this function CreateWindowX is located. Now, the easy thing with MSDN is that if you scroll all the way down, some of these descriptions can be huge, you can see the actual DLL that this function resides in. So we know it's in user 32, and this is the name. So if we go back to IDA, if we switch to modules and sort it by name, we need to scroll down to user 32, double click it, and then I do Control F on the keyboard and then type CreateWindowX. So, and then if I double click on it, sorry, I need to, this is kind of stupid thing about IDE, you have to put the cursor into the disassembly window and then double click. So this kind of tries to show you inside user 32 CreateWindowX, except it doesn't, because it probably doesn't have symbols loaded. Now guys, in case you have this kind of nonsense shown, which obviously is not, you know, is not the correct disassembly, what I usually do, I go to modules, I locate the module, I right click, and I hit load debug symbols. So this should load symbols, and I'm assuming also analyze this module. Now, originally it might take some time, because, you know, especially if you have a new installation. And let me see, why is it not showing? Yeah, in case you have a new installation, it should technically show. Well, I guess I'm not sure what's going on with IDA here. Oh, okay, I'm sorry, guys. These are input parameters, my bad. So many of them, it kind of looked like these are just data points. So you have to scroll down a little bit. Again, sorry. And this is where the actual code starts. Well, let's just check real quick what's happening here. Obviously, this is a huge function because, you know, it's responsible for creating all the windows. But if you look at it, it's not really that big. What you see internally is that it calls something that is known as CreateWindowInternal. Okay? And something tells me that CreateWindowInternal is doing most of the work. Yeah. Okay, well, this is interesting. So let me kind of quickly search by this name to see if it's, I know it's not documented, but let's see if anyone tried to reverse engineer it. And yeah, somebody saw it over here. Oh, it's some kind of exploit. Okay. So where is the definition? Oh, okay, yeah, it's just a call stack. Yeah, interesting. So it doesn't seem like web contents. Now this one, oh, it's a Chromium source. Yeah, they're also using it. But where is the actual function? I don't think it seems like it's their private function. But what this basically tells me is that nobody had reverse engineered it. And I'm talking about this again, CreateWindowInternal. In our case, you see the problem is, the reason I'm kind of looking into like the deepest function that you can find is that there are many ways how a window can be created. Just to show you, just to give you an example, if you take like the root of the function CreateWindow, and if you start my WinAPI search, and let's say if we search in 32, system 32, and let's say we search for DLLs, and we search for exports. In other words, we want to find where a function with CreateWindow all functions with create window are coming from, and also all the variations. If we search, so yeah, as you can see, let me like expand it a little bit. So you can see there are quite a few create window functions. Like this is the one that we kind of like had documented here, but there's also create window in band, create window in band X, create window in direct, and then there's like all kinds of C++ functions. So because we don't know how exactly it is done inside the snipping tool, we kind of need to catch the most internal invocation of this function, because quite a lot of these are just shims. Like in this case, as you can see, create window X, right, the one that's documented, is technically a shim for create window internal. So in this case, ideally, you would want to put a breakpoint inside create window internal, but the problem in this case is that we don't know which parameters it's called, because it, as you can see, assumes a lot here, and obviously, because it's undocumented, we don't know. So in this case, what I did, I kind of risked it, and instead of dealing with the internal function, because it wasn't really well documented, I put the breakpoint here on the create window. Now, in this case, it's not very difficult to reverse engineer and see which parameters the create internal is receiving, because as you can see, we have internal parameters for create window X, and as you can see here, it passes them almost unchanged into create window internal. So, but in this case, I kind of risked. But in real reverse engineering, if you really need to find, like, to catch every single instance of window creation, you can definitely dig at the lowest user32 function. So in this case, it is probably create window internal. Okay, so this is a little bit of theory, but let's kind of run it. And we hit our breakpoint almost immediately. And let's see, yep, create window X. Now we need to kind of see what exactly is it creating, and the easiest way for us to go by is the window class. As you can see, is the second parameter. And just to kind of quickly explain, window class has nothing to do with C++ classes. Window class is kind of like, it's like a string, unique string that connects it to any window tool to its window procedure. And the window procedure is kind of like, it gives you like the properties of the window or what it does, basically the code, underlying code. And the second parameter is what we need. Now, if you remember, guys, in my first tutorial, I actually wrote this little layout here for the calling conventions. So let me kind of like copy and paste here. So x8664 calling convention, like, again, this is not a video about it, but real quick, it passes all parameters like in various ways. First 4 would be passed in registers, RCX, RDX, R8, R9, and the following parameters are passed in a stack. And this is the stack before the function is called. So obviously, if you step in, it will be offset by 8 bytes, because, over here on the stack, you will have a return address. So this is before function is called. Actually, it should be on top over here. Okay, so this is basically our little cheat sheet to know which register parameters are passed in. And in this case, because we're dealing with the second parameter for the class name, it is passed in RDX. So let's see, what do we have here? And in this case, because we are inside the function, this calling convention, the RSP would be offset by 8. And this is when function is invoked, or inside of it. Okay, so this would be the difference. So instead of offset 20, offset 28. But in our case, all we need is RDX. And if we look at RDX, so what we're getting here is not a pointer to a string. In this case, as you can see, the type is pointer to a string, but instead it's an atom. Atom, it's kind of like a really old school way to pass kind of like a handle. So in this case, it tells me that we're not interested in this call. Let's keep going. And in this case, it is also not very interesting because, again, what I'm checking is RDX. So let's just keep going. And what is nice is that IDA, you see like over here on the right in the register pane, if the thing is a string, it actually displays it here. So right now the class is Microsoft Windows Snipper Editor. And if you remember, what we're looking for is Microsoft Windows Snipper Toolbar. So we keep going until we see that class. Okay, it creates toolbar. And again, what I'm doing, I'm looking at RDX register here. And again, something else. Okay, uses the atom, a handle, another handle, and snipper capture form. And that seems to be it. Let's double check. Microsoft Windows Snipper Toolbar, and the easiest way would be to copy this thing. Because again, you don't want to miss one letter, because obviously if it's one letter mismatch, it's not going to work. But in this case, yeah, this is what we need. So this specific call to CreateWindowEx creates our toolbar. So what is important to do, guys, is to understand how CreateWindow works. Let me just give you kind of like a bad example. Like, let's say, hypothetically, because you are inside this function, you need to step out of it to see where did it come from. You can technically step out by going in a call stack and by clicking addresses here, but the best way, not sure why it didn't work, let me check. Yeah, it's something specific to IDA. But anyway, guys, technically what you need, since you are inside this call, you need to step out. There is a function which is called run until execution returns from the current function. Well, if you invoke it, let me see what happens. Instead of returning out, you get another hit on CreateWindowEx with the toolbar. Now, definitely for me, when I was starting out, it was very confusing. It's like, hey, wait a second, I'm trying to step out, but then I got hit by this breakpoint. Well, what happens is that inside CreateWindow, let me see if it mentions anywhere. It's like a giant description here, but basically, oh yeah, what it does, it starts calling, like it starts sending these messages while the window is created. And inside of one of these messages, probably NC create or window message create, inside the processing of that window message calls another create window with another class. So in this case, you have to be careful and kind of like step out differently. So let me show you how you do it. At this point, we kind of blew our chance because we just hit a breakpoint in a totally different spot that we didn't need. In this case, let me stop it. And not sure what IDA is doing here. It's really slow. Okay, so start over. Again, like I explained in the first tutorial, reverse engineering, it's like starting, terminating, and you can do it like 100 times. So we're in WinMain. Let's run it, and we're going to hit Create Window. And again, in this case, we'll look at RDX until we hit our Microsoft Windows Snipper toolbar. Now, guys, hypothetically, we could have created a conditional breakpoint if you went to edit, and then we create RDX equals, and then we have to read the contents of RDX and also make sure it's not an atom, and kind of make a conditional breakpoint. To be honest with you, it's so complicated. In my view, if you just have to hit the go button 5 times, it's way simpler. So what I'm doing, I'm hitting go button or run, I think, start new, well, basically this triangle, and then check RDX until I see my class that I'm looking for. And in this case, Microsoft Windows Snipper Toolbar. So let's do it real quickly. So skip this one, skip this one, skip this one, skip this one, this one, this one, and Snipper Toolbar. So what we need to do in this case, we need to mute this breakpoint or disable it, and then we can use run until execution returns. So as you can see, in this case, we returned from the function without actually triggering another instances of the same breakpoint. So this is kind of like an important part to notice. And at this point, we are somewhere inside the process, the snipper tool, the snipping tool. The reason I can tell is because this text thing, it basically gives you the name of the section inside the binary, inside the PE file. And this is where it is creating the window. Okay, so what I'm looking here, I scrolled up, and as you can see, we are inside the helper class. So this helper class, like literally, is a shim for CreateWindow, and it doesn't do anything else. So let's step out of this one as well. And we're still inside the snipping tool. And this one is kind of interesting. Let me see what it's doing. Create window, style. Okay. Yeah, this one looks like a larger class, and it says init toolbar, init bar. So just to kind of give us a little bit of perspective what's happening, what I usually do, I copy these things into my notepad so that I know. So I'm kind of like thinking that this init bar is something responsible for creation of this whole thing, although init bar doesn't really, yeah, the name doesn't really match, but well, who knows, maybe they didn't care to change it from the first name. Well, let's see what they're doing here. So they call their constructor, they call some kind of logging function, it's internal Windows logging function, and yeah, and then they invoke this. Oh wait, they're creating a toolbar. Why are we? Interesting. I'm not really sure why did we get here. Yeah, let's see. Create window and RDX, right? So the second parameter, RDX should be our class name, and it's RSI. So what I'm doing, I'm kind of like tracing back where did the RDX come from, and as you can see, IDA helpfully shows me that this is the class name, but they copy it from RSI, and RSI comes from RDX, and yeah, so comes from over there. Well, let's jump back. So basically it's the second parameter of that function as well, right? Because if we take RSI, it's RDX. Let's jump back to IP and RDX. Yeah, so they create a class. Okay, guys, this is interesting. Hold on. I think I need to set, yeah, let me set a breakpoint on this guy. And let me make sure that my other breakpoint is neutered. Okay. And so technically RDX, yep, it should be the name. Yeah, should be the name of the class. And we just created it, so have to start over. Let me just see what happens in that helper function. So again, I'm kind of like, let's see, where am I? Okay, when main, I think our breakpoint will still remain. Okay, so again, we're in this helper function. Again, for some reason, they wrapped all the Win APIs inside of the helper class. And also our DX is the one that gives us, you know, the class name. So again, we're looking for our Microsoft Windows Snipper tool, I think. Not toolbar. Did I hit the wrong one? Yeah, Microsoft Windows Snipper toolbar. And come on, Ida. I can't just double click. Oh, I think I hit the wrong. Yeah, in the previous example, I was in the wrong function. Ooh, okay, yeah, this one is more promising, so let me get to this one. And let's see, probably wrong guess. And again, I'm just keeping this just as my own notes. Obviously, in real reverse engineering, no one will ever see them. It's just kind of like things that I leave for myself. And over here, let's see, create window. What I'm doing, I'm basically adding breakpoints, and in this case, our DX would be the name of the class. And let me see. Yeah, so RDX, yeah, hold on, this is a snipper form. Interesting. Okay, let me start over. Again, I neutered some of these. And okay, so we don't need a breakpoint on init, right? Because this one, let's see, what does it do? Oh no, we do need in here. Yeah, we don't need this one. Let me disable it. So if I run it again and see when it gets hit here. Okay, we don't need the capture form. Interesting. Okay, so I'm obviously on the wrong track here, so I have to retrace. So my guess here, so init, let me disable it. And let me check this one. So I have to go back and enable breakpoint. Again, have to start over. And okay, so it got hit on Snipper Editor, toolbar 32, capture form, Microsoft Snipper toolbar, and this is what we need. Yes, Microsoft Windows Snipper toolbar. Well, let's step out of it manually. Just need to make sure that it's not called again, and it shouldn't, because again, this is the wrapper for the create window. Oh, okay. Well, I guess they are calling the same function, so that was my problem. So again, guys, I'm kind of like eating my own dog food here. So let me explain what the problem is. So when we get, again, I'm looking here, when we get to our snipper, not form, toolbar, so what is happening here is that they call this function again from within window message create, which is called internally. It's kind of like sort of recursion here, which is somewhat confusing. So make sure to like place the breakpoint correctly. And again, I'll explain what this is and how to do it. But basically, like I showed, create window calls one of these functions, and inside of these messages, not functions, messages, inside it invokes this create window X, and that's why we get, when we step out, we get in the wrong location. So what we need to do is disable breakpoint and then step out. Okay, let me see if I'm close. And I'm again in Toolbar. Let me step out again. And in this case, okay, on Create. Okay, this gets a little bit closer, but we're still nowhere near where we were. I think, guys, if I'm not mistaken, this run until is not really working well. Let me double check. Hang on 1 second. It shouldn't be like returning us into some location where we shouldn't be. So yeah, this is what reverse engineering is. So you kind of like learn as you go and you retrace your steps. So what I did, I enabled that breakpoint again. So what I want to do, I want to step out of it manually because I don't think this function is working properly. So again, I'm looking for the class that I need for snipper toolbar, capture toolbar. Okay, so let me disable this thing. Technically, I should be able to just double click on this thing and step and show the code, but for some reason either this version doesn't want to show it. So let me just step out of it. It's very simple. Okay, create window. Okay, it did create it, which is nice. And we're still in the same function. And we are, okay, destructor for the logging function. And we come out here. Interesting, they do create a toolbar, even though on the input. Yeah, guys, I need to investigate it. Hang on. Now, how can they be creating a toolbar when we're actually creating a different class? So let me enable breakpoint, have to start over again. And yeah, you see, like this is the fun you have to go through. So again, let me get to the actual call, snipper editor, toolbar. Okay, so this is what we have here, and let me get to the actual call for create window. So for create window, the second parameter RDX should be our snipper toolbar. And let me approach it differently. Again, I'm disabling the breakpoint, but I am adding it here. This is another approach. Instead of like doing, stepping in and stepping out, you can just run it. Okay, this is wrong because again, we're inside this toolbar button. And again, when I'm looking at RSI, which I believe, let me see what, RSI is a class name. So let's keep going. Okay, so over here, because you see that RSI is our snipper toolbar, so what happened is that inside one of these messages, they were calling their own helper CreateWindowX on all of those other classes. So we kind of got like our breakpoint hit on many instances. The thing that kind of puzzles me is why this button didn't work, but again, this is the either thing. But anyway, so right now we actually caught the correct class. So let's step out of this function and show where we actually emerge. So again, real quick, it's probably faster to just step through. Okay, R15 is the name of the class. Okay, and as you can see here on the right, this is what we need, and let's see where is it coming from. Yeah, and what I'm doing, I'm kind of highlighting it. Oh, sure enough, here you go. We are in the right spot. As you can see, R15 over here is what we need. And let's see if we scroll all the way up. We are in CToolbar, init toolbar. This looks like what we need for sure. So let me highlight and copy this. And most certainly this, not the spot, the function. Now this is just a function, but what we found here, yeah, you see, like, guys, they're registering the class, which is this class here. They're providing window class, which is the handler, and they do all kinds of internal stuff, some system metrics. And over here, this is the location where they are actually creating our window. So to double check, we put a breakpoint here. We pretty much remove, what is this one? Oh, okay, that's the one that we just set. And we don't need this one, so let's delete breakpoint. It's important to delete these because you don't really need a lot of them. Let's see, how do you delete it? Delete. And this one, it's inside CreateWindowX. Well, let's just keep it in case. Okay, so let's stop it and run again. So technically the first time we're in WinMain. And the second time, yeah, this is where they create the actual toolbar. And as you can see, now we need to understand what are the input parameters for this function. Now, if you check on the right, just copy the whole thing because IDA unfortunately is not very good with colors, or if double tap on it. And yeah, it's more readable here. Okay, so first parameter I'm reading here is styles, class name, window name, style, a bunch of ints, int. Something tells me that these things would be the location and the size. Now, if you look at the actual create window, I think they just replicated it one-to-one. Yeah, so X, so first 4 parameters, and then X, Y, width, and height. So obviously they don't have to copy it one-to-one because you see here it's a little bit mixed. But something tells me is that those parameters are the ones that have our location and width and height. So let's see what kind of height they specify here. So what we need is to count, like this is first, second, third, fifth. So fifth, I'm sorry, first, second, third, fourth, fifth. Let me just write it down. So we're interested fifth, sixth, seventh, and eighth parameters, right? Okay, so let's see, where are we now? If we go to jump to IP. Okay, so we're about to step into this function, and let's see which registers these parameters are coming from. So because we're before entering the function, it's our 5th parameter, which is this. And basically, because it's hexadecimal numbers, it's very easy. It's like 30 and 38. So these are the 5th and so forth, right? So let's see. And IDA kind of shows us here. Now, unfortunately, let's see, how do you... Yeah, like this stuff in IDA is very, very confusing. Let me try one trick here. So if I show disassembly, I'm sure someone will probably tell me how to turn this thing off. Again, I'm not usually using IDA for my everyday stuff, so I'm kind of not dealing with this. But there's probably a way to turn this into actual offset, because if you copy the machine code, and if we go to disassembler online, and kind of got used to this one. So if you disassemble as x64, you can see that this is, so this machine code, which IDA shows us here, it's not this BS, right? So if you take it, let me just show you real quick down here in my notepad. Okay, this is what IDA is giving us, but in reality, the actual instruction is this one. So as you can see, if we remove all this stuff, so this is the offset and not this. I'm assuming that IDA is trying to be helpful with this stuff, trying to analyze the input parameters, but this is very, very confusing. I should probably look up online, I'm not going to do it live, but to remove this and kind of like make it displayed like this. But what is important for us is, as you can see, there's this 28 code, and if we look at the machine code or the instruction, this 28 is most certainly the offset that's displayed here. So, but what this tells us that this is the 6th parameter, and EDX in this case, let's see, where is EDX? Seems to be, oh, okay, we overrode it. So yeah, basically EDX has been overwritten here, but if we look at our stack, as you can see over here, bottom right, so we need the 5th parameter. And what is happening here is that this is the 1st, 2nd, 3rd, 4th, and 5th. So 5th is 540 hex. So if you look at 540 hex, it's oops, no, we don't need to do that. It's 1344. Now, to be more precise about this thing, what we need to do, we need to make a snapshot of it. We need to copy, open a Paint app, paste it into it, and actually measure what is the size of this window, right? So if we go kind of like roughly drag around it, at the bottom, let me start over. So when I try dragging, you see at the bottom those numbers that are changing. This is the width and the height, and obviously this is approximate. So the approximate width is 718. Let me just write it down. Approximate width, and just the size and width is, I already forgot. Let's see, 718 by 532. And we need to convert it into a hex number. So this tells me that this is something else. This is probably a coordinate. So let me do, okay, Microsoft, here we go. So 718 in binary is 2CE. In hex and 532, 532 in decimal is 214 in hex. So this is approximate size of the window, and this is what we're kind of looking for. So let me go back. Okay, so then we have this instruction, which is setting 2C, and 2C, let's see, yeah, so 2C it would be 2nd parameter. Let's double check. And then we have 38, it's probably something else. Okay, 38 would be something that was passed in ECI. And then 40 and 48. Interesting. They are, yeah, our ECI is a lower 32-bit of RDI, and they pass 0. Well, actually, you know what? Let's just check here. So, yeah, this looks like, again, what I'm looking for, this one would be the 5th parameter, and because they're using only 32 bits, because we're talking about ints, in other words, if you look at the parameters there, it's 32-bit ints. So on in memory, it's just using lower 32 bits. So they're passing 540, 8C, 12C. Let's look at that. Yeah, and then the last one is 0. Let me check something. What if I pass this parameter? Let me just change it. Let's say edit and just set like a huge number here. Now to save it, unfortunately, if you hit enter, nothing will happen. You have to hit F2 to apply. And let's step over it and run it. And nothing changed. Interesting. Yeah, the window is the same size. Okay, well, what this is telling me, guys, is that they are not, when they create a window, let me start over again. So when we get to this point, when they create our snipper toolbar window, they don't have the height. Let me just check if, let's say this one, let's assume that this is, just zero it out, and let me apply, which is the most annoying thing, and then edit this one also into 0. I'm assuming this would be the coordinates. If you run it, oh, interesting. Oh yeah, here you go, guys. You see, those two parameters would be the coordinates of the window, and because I set them as 0, it literally put it in the top left corner. So this tells me, let me just start over and get to it again. So this is X, this is Y, this must be width. Let me just edit it and create some huge width. So if I'm correct, if I run it, oops. Oh, interesting. You see, it doesn't, the window doesn't really, the width and height don't really affect the window. It's using only X and Y. So what this tells me is that when they get to this point, you know, when they create a window, they don't know the height, obviously, because you see the height here is set as 0, but also the width is also changed later. So this also complicates things. It means that this function is not where they set the height. In this case, we obviously care only about the height of this thing. So this is not where they set it. Now, when I refer to my programming experience, I know that there are other functions where they can set the size of the window. One is the old one, so-called MoveWindow. It allows, once you have a handle, specify location and also width and height. So let's try to, you know, see if they use this API. In this case, it also resides in Windows 32. In user 32 DLL. Let's locate user 32. And again, I'm sorting it by name. Double click, Control F, move window, and let's add a breakpoint to it. We don't need any conditions, just any breakpoint. And let's see what happens. So let's step over and run, and the breakpoint didn't hit. Okay, so this tells me that they do not use MoveWindow. And let me, oh, it's not even present here. Okay, so let me go back again, start over. In this case, because we have this breakpoint, we know exactly where they create the window. And again, guys, to kind of quickly recap, I'm not sure if I'm going too fast. After they create the window, their main window, this one, you know, the outlines, They don't specify width and height, they only specify the position of the window. The width and height is probably calculated later. And one way to do this is by using MoveWindow function, but as we just noticed, it didn't, the breakpoint on this function didn't hit. So then there is another window, another function that is often used, and this is SetWindowPosition. This is a very multifaceted function depending on the flags, but basically it can also set width and height as well as the position of the window. So let's see if this function is hit. And if we scroll all the way down, it's also in user 32. So let me clean up my breakpoints. So MoveWindow is obviously not what we need. And again, we're doing the same thing. Sort the module list, find user 32. Oops, this slide. Double click, Control F, and set window position. Set a breakpoint. Let me go back to my previous location and step over. Ooh, and then we hit this function right away. Okay, guys, now set window position is also the function that is called quite a lot, and with the difference of the first function CreateWindowX, where we were looking for the class name. In here, we have to look at the handle. Now, unfortunately, I did not remember the handle. So, in this case, let me disable the breakpoint. Have to start over. And what I suspect is happening is that they're using the set window position in many places. Because again, this is one of those generic functions that basically moves and changes Z focus and all kinds of things for all kinds of controls. And because they're creating it manually, something tells me that this thing is called a lot. So we need to find some new way or interesting way to actually, or clever way, I guess I should say, to find how we can trap it. So what I'm proposing, let me just step over creation of the window, because again, before the window is created, we don't really have anything to say. And in this case, we need to see, is this the handle of the window? So if we copy, and let me just do H window handle, just all of this stuff. And without doing anything, let me see if this is the main handle of the window that it's creating. So if I just run it and start, then if I run my WinID tool, just hit here. Okay, if I mouse over the window and hit Shift, go here and copy this window handle and paste it here. Yeah, so guys, you see like that function that we were in, that the one that created our toolbar, what it returns is a window handle. And as you can see, window handle for the main window. Oops. So, and this is what we need to play with. So let me explain what I'm going for. Like, if I start it over, WinMain. Okay, so this function is the one that creates a main window, and when it returns, this is our handle. The difficulty in this case for us is that the window handle will be constantly changing. But we can still remember it, right? So when our set window procedure is called, this one here, we need to catch only the moments when its first parameter is set to our window handle, right? Because the rest of it we don't really care, because like right now, let me show you, if you run it, Ooh, that is pretty stupid. I didn't enable the breakpoint. Sorry. Let's start over again. At least we know what we're doing at this point. So we get to our creation, window creation function, step over. We get our window handle, and again, unfortunately, will be a new value every time. Then we need to get to our breakpoint, enable it, and let me show you. So when we run, this thing will hit right away. Now what we're looking for is the first parameter, which tells me that this is RCX. Again, if you look at our calling convention, first parameter is RCX. And let's see what the RCX is. It's 1B0668. And this is close, but this is not what we need. Again, if you minimize it, you see the RCX is not, in other words, this is some other window. Now, in this case, I would definitely advocate for setting a conditional breakpoint. So let me show you how you can do this. Now, if you go in the breakpoints window, if you right-click Edit, and over here, where it says condition, we need to see that RCX is equals to our window handle that we have over here. In other words, don't trigger this breakpoint unless RCX, or the first parameter, is what we need. Well, let's see if it works. So if we get it to run, I think we just hit it. Yep, here you go. Happened so quickly I didn't even notice it. So yeah, like as you can see, RCX here is what we need for our handle. Okay, well, let me well, let's see if step out actually works. Okay, Ida. Well, this is one of the reasons why I'm so annoyed by this Ida thing. Like, why would it be giving us breakpoints, right? Something in it basically didn't work. Okay. Does it mean I have to start over? Yeah. Sorry, guys. Yeah, I'm not going to be doing this. So let me just do it manually. At this point, I have to disable. I have to remember to disable my set window position because it will be called many, many times. Okay, so here we are creating the window. Let's step over. We need to get our value for, for the window handle. It's this one ending with 28A. And let me copy it and then go back to this breakpoint, enable it. And the reason I know is because of this comment here. At least that is helpful in IDA. And what I need to do, I need to change this condition. I know it's really small, guys, but I hope you can see it, to our actual handle. Then run it. And at this point, let me disable and manually step out. Now at this point, I think it hung up and we're inside the system library. So let me just step out, and we're getting to a syscall. So it will go to kernel to actually do the work. And what? We crashed again. Okay, well, let me see, why is it doing this? Let me save everything and restart. It's just unfortunate that you have to do this. So let me restart the project, so maybe it will let us do it. So let's start over. So technically we should be, okay, when main, get to our function, created a window. Let me copy window handle. Breakpoints, make sure it's calling here. Okay, so we need to enable this one, guys, unfortunately I can't enlarge the font here in these windows, or at least I don't know how to do it. So I hope you can see it. So we right click on the breakpoint, we go to edit, and edit out our window handle, run it. Okay, well, let's try to do the stack tracing. So we're in this location. If we copy this value from the stack, again, I don't know how to coax IDA to actually go to this location, and if I click G, it should technically take me to this location. Oh, okay, sorry guys. This is not the return address. That's pretty stupid. This is the return address. Yeah, if I double click, nothing happens. Let me try to copy it. I hit G. Okay, so this is where we're setting this position. And let me see what kind of function is it. Set window position. Okay, so yeah, it's basically the does it have a call stack? It should have a call stack. I think it should be available. Toolbars, debugger, debugging windows, threads, stack view, stack trace. Oh yeah, look at that. Okay, yeah, that's really helpful. So instead of doing this manually, I can just, what just happened? Call stack. Oh, okay, so yeah, by double clicking, oh, here you go. So the call stack window is the one that shows the actual call stack, or which functions, kind of like a tree of functions that were called. And we are actually in a really good spot. Like the set window position is called, yeah, looks really promising. So if I scroll all the way up, but I already see it right here. If you scroll up, update DoLayout. Yeah, okay guys, this is a very promising function. Let me copy it and DoLayout, and let me save it. The layout is kind of like, if you look at pretty much any app, like the way programming works, GUI programming, is that you create everything and then you lay out depending on the size, the DPI, and so forth. So this is most certainly is where they're doing it. So if I go one step above, we're still in DoLayout, right? So let me put a breakpoint over here. And yeah, let's see, and also let me remove, not remove, but just disable. And let's see, what else do we have? Okay, this is that one. Okay, this is the one that we create, and I'm assuming that won't be hit again, but it is hit. Interesting. How many times is it hit? Let's see, I'm looking at the call stack here, and we are inside our DoLayout, which is, let's see, where is it called from? Yeah, it is inside of our DoLayout. It's the same stuff that we saw before. Let me jump to IP. The only interesting thing is that they call it multiple times. Okay, so RCX is the window handle, but at this point we don't know what the window handle is. Interesting. Yeah, it seems like they are reusing it. Let me start over and kind of like try to get the actual window handle. Again, the reason I'm restarting it is because at this point in time, interesting. Yeah, so they're calling it, sorry guys, yeah, basically over here in this function where we create the window, we need to know the window handle afterwards and use only that window, because, you know, it seems like they're reusing their helper functions for pretty much anything else. So, okay, let me start over. It seems like I have to remove this breakpoint, not remove, but just disable. Okay, and we create the window. Get the window handle over here. Again, have to save it. This is kind of the annoying part, when you have to basically remember this thing every time. But in our case, if we go back to this thing where they're doing the layout, so let me just enable this breakpoint and set window position. If you remember, the first parameter is RCX, but in this case I won't be setting conditional breakpoint because I want to see how many times they're calling it. Okay, so RCX is it our window? No, 246. This one is something else. Okay, and this is our window here, and they're calling it DoLayout. Did I put a breakpoint in the wrong spot? Yeah, it seems like that's what I did, guys. This, unfortunately, binary code is so confusing because, again, you have this assembly instructions pretty much everywhere. And let's see, what is this thing? Just window. Send window message. Interesting. Okay. Yeah, this is DoLayout. So why did I put a breakpoint in that other spot? Yeah, let me remove this one from here. And let's see, RCX. I think this is our window. Yeah, 246. So they're calling it more than once. Wow. Interesting. And then, oh, they call it again. Okay, that's my first window. Ooh, okay, that's really promising. You see, they're using this function, this DoLayout, to actually calculate something and change, I'm assuming, change window position when I activated the window. So you see, if I let it run, it continues running. But then if I try to bring the focus to it, it hits the breakpoint. So we are at a very promising location. Let me start over and see. So without disabling that breakpoint, so first we're in WinMain. In second location, we create the window. Yeah, and then we start calling this DoLayout multiple times though. Okay. This is really, really interesting, guys. And it seems like we're in the right spot. So let me start over. At least we've found, so what we've done so far, we found the location where they may be setting the size. And the way they're setting the size is by using, well, in this case, all we care is the height, by setting the CI parameter for set window position. So let's get to it first. So if we step over our window, let me just copy it just in case to make sure that we're not on the wrong track. It's this 2A0668. Then if we let it run, so the RCX is 2A0668. Yeah, this is our window, as you can see. And in this case, let's see, what are they passing? So the interesting thing, okay, now guys, in this case we also have to make sure that we have the right flags. So if you look at the bottom of the WinAPI thing, of the description, if we have a flag which says no size, this means that CX and CY are not used. And the flag is 1. So basically, if they didn't set 1, kind of like a lower bit of the flag, we should be good. So let's see where it is. So it's like 1, 2, 3, 4, 5, 6, 7 parameter. And if we go back to our cheat sheet, but you know what, the easiest one would be to go to stack and go like 1, 2, 3, 4, 5, 6, 7. So 16 is the even number, so you can tell that the lower flag is not set. And this tells me that they are actually not, that they are setting the height. So in the height is again 1, 2, 3, 4, 5, 6 parameter, and it's passed on a stack in this case. And we go like 1, 2, 3, 4, 5, 6, and the height is 220. If you remember, we calculated the height, and it is really, really close. Now, obviously what I did, I just kind of like did a quick outline with the paint here, but I might have missed a few pixels here. Let's try something, guys. If we edit this and instead of 220 we create 330, right? Just kind of like to see if that's the right location. And apply changes. We have to run it again, and again the same height here. We edit it and make it 320, basically just add 256 pixels, and run again. And for some reason they're calling it many times, what seems to be with the same parameters, but who knows, maybe they need it for some reason. Okay. While we're running, let me minimize this window and see. Oh wow, look at that. You can see on the screen, right, that this is the app that I was working with, and this one on the left, the one that shows the circle, is the one that I just modified. So this basically tells us that that location over here, this 220, is the height. So we're really on the good track. The only thing we need to do is to see where this parameter is coming from. So in this case, we need to analyze the input parameters. In this case, let me see what is happening. Now, IDA is showing us X and Y, but then it is not really showing us these things. So it's either this one or this one. And the easy way to tell is just by looking at them. R9 is 0 and RBX is 14. Did something override it? Oh, okay, yeah. Most certainly. Let me just put a breakpoint here. Now the dirty trick, instead of trying to decipher which one of these parameters is the real one, I'll just put a breakpoint here, because we're technically looking for the value 220, as you can see here. This is the height that they're setting. Again, let's see, real one is 220 hex. So we're looking what exactly is setting this. So if I run, then bring the focus to the thing. So R9 is 0, but oh, sorry, what am I doing? It should be, oh, wait a second, there's a branch here. My bad. Okay, we need to delete this breakpoint, and let's see, it's coming from another branch. Ooh, that's interesting. Yeah, I need a breakpoint over here. So let me see. Yep, and this one is the one that hits. Okay, RCX is 220 and EAX is something else. So this tells me that our ECX in this case is the height, right? So, yep, so just set over here to 20. And let me see, so we don't need this breakpoint. And let's see where this RCX or ECX is coming from. The good thing about IDA is when you like click on something, it literally highlights all the references, like for instance ECX and RCX in text. So let's scroll up and see what we are doing here. Now unfortunately they're doing some calculations here, but there is a branch, and yeah, that comes from a lot of places here. Okay, in this case, guys, the easiest way would be to go all the way to the top, to the beginning of this function, put a breakpoint here, and just step through it and see what is it doing. So let me run it. Okay, and then again to hit the breakpoint, let me refresh, not refresh, but hit, bring it to the front. And right now we're in this DoLayout. So let's just step through it. Well, first of all, let's see the input parameters. And this is kind of interesting. Now, obviously, as you can see, this is a class function, and this is also a member function because it's giving this parameter. But then it also gives it a rectangle, and this is kind of interesting. Let me see what is in this rectangle. So if you know kind of like a calling convention for C++, for member functions, the first parameter is this. So it's passed in RCX. So this thing here is this, and RDX is a second parameter. But the RDX is actually 0, so they're not actually passing anything. Interesting. That probably tells me that they calculate this rectangle internally, or maybe it's a return parameter, so it could be anything. So anyway, let's step through it and let's see what happens. It doesn't seem like there's a lot of code here, so we'll do it pretty quickly. Okay, so this is just a logging constructor. We're not really interested in it. Okay, and then they are sending a message. Now, unfortunately, they're using this value, which is just a hex value, and we don't really know what this value is. Now, to figure this out, I'm using a technique where I use Visual Studio, and I usually create a short kind of like a really small C++ app. In this case, it doesn't have anything. What I'm including in it is Windows H, and then I would try to locate what is the value of this 421. Now, from my experience, now if we look at, let's say, window message create, like the good thing about Visual Studio is that it has that IntelliSense, which kind of helps. But anyway, if we look like at the most like well-known messages, and if we go and peek at definition, most of those values are kind of really low. So let me just go to definition, open it in its own file, and let me try to search for value 400. And as you can see, it doesn't have anything. It's like these values don't go this far, because most of these window messages, they start from kind of, oh, hang on, let me go back. They start at kind of low numbers, and they don't really go that far as 400. So, but then there's also something called Windows Message User, and if you know Win32 programming, these are messages specific for each control, so they could be using that, and this gives you the actual 400. Now, the tricky part about Windows Message User is that this is specific for each control. You see, like what they do, they just do like, you know, like for this message, it's Windows Message User plus 0, plus 1, and so forth. So in our case, what we're looking for is 421 hex. So let me do it here. It's Windows Message User plus something, and what we're looking for is this. To understand it a little bit better, we need to look at this window. So what is this window? So basically, in other words, where are they sending this message to? So let me get RCX and just copy it. into our notepad, right, is 5DA at the end. Yep. So if we briefly neutralize this one, and also I believe we need to neutralize this one. What I'm trying to do, I'm trying to run the app itself and see which window has that value. So if I run it, if I bring it to the top and use my WinID, so what I'm looking for is the window with the handle 1B05DA. And yeah, so like over here, like it's really small second line where it says HWND. If I point at Windows, it gives you window handle. And if I point here, you see 1B05DA. This is the window which we had for that send message. And if you look over here in WinID, where I'm pointing with the mouse when I do this, it's a toolbar class name. So what they're doing, they are sending this message. Well, hold on, let me get to it. So let me start the app. Again, have to start over. Get to create window. Get the window handle. Now in this case, it's not this one. This is the window. And let me do main window. So we have too many handles here. Okay, and then we need to enable our breakpoint, which I believe is this one for the layout. Right, do layout, okay. And at this point, so let me step over till we hit that send message thing. Okay, so what we're trying to determine is what is this 421? Well, 421, we know that they send it to a toolbar. In other words, this is the user message for toolbar. In this case, we can use MSDN, and we can say MSDN toolbar notifications. And make sure it's Microsoft website. And what we need is to see which notifications does the toolbar receive. But hold on. No, it's a notification area. No, it's not. No, we don't need. Yeah, Microsoft. Hold on. Let me try something. We need the class. Let me make a snapshot. We need notifications for this class. Okay, so yeah, for some reason Google gave me the wrong notifications here. Common control. So again, we need to find notifications for the toolbar class. Okay, that's what we want. Getting a little bit closer. Okay, is it tooltip? No, sorry, not tooltip. What am I doing? Toolbar. Okay, class name. Okay, again, the wrong place. And then following toolbar class name. Now, what is this thing? Okay, some kind of, okay, this is perfect. So they're using toolbar class name. And okay, so these are, as you can see, send message. They're sending something to a toolbar. And this is type of the notification that we need. So we need to take it to our Visual Studio and see the actual value. But before we do that, we need to get the actual, what is the header that we're missing, and we need to include common control. And so we do here, include that, and that should basically let us have the symbol. Okay, and then we go in there. Okay, and this is very promising. So what we're looking for is basically user plus 21 hex. So what is this? So in this case, okay, because we have the value that is a hex, so we need to convert it into decimal, which would be 33. And so all we have left is just to locate it here. And sure enough, yes, TB auto size. So what this thing does, it literally sends this message. And I'm not sure where it went. Is that how you add a comment? No? Anyway, it refuses to show it. But basically, when they do this 421 hex, they are sending a TB auto size message to the toolbar. And the only thing left to do for us in this case is to locate this message and see its documentation, because all this stuff is documented. And what this does, it causes the toolbar to be resized. So what this does internally, if you know programming, so when you create a toolbar, you don't know how much space all these buttons and text will occupy inside the toolbar. And when you send it this TB auto size message, it makes the parent window to have the same width as the toolbar, you know, with all the borders and stuff. So this is what they're doing here. So when they call this function, it resets the parent window to be that specific size. But then they also call, as you can see, to the same window, because they take it from the same location, another message, which is 453. So let's see what that thing is. So, just to trim it up a little bit better, so 421 is this, and 453, if we follow the same logic, if we do 53, it's 83. And then if we go 83 here on the list, get max size. Okay, here's another message for the toolbar, and it kind of makes sense now. So let me save it. So then if we search by TB get max size in official documentation, so what this does, it retrieves the total size of all the visible buttons and separators of the toolbar. So in other words, what they do first, they make main window resize, and then they ask the toolbar, hey, what's the size basically of the things that you're showing here? And as you can see, L parameter, or the second parameter for the, not the second, but L param contains the pointer to the size that receives it. Okay, well, that kind of makes it pretty promising. So again, they retrieve all that information. Let's see what they do next. They're calling this function, which calls millimeters to pixels. Let me see what it does if we step into it. Oh yeah, so basically it converts sizes, pixels, using the DPI, and DPI is the dots per inch, like when you set resolution for your screen. And yeah, it does some math. Yeah, nothing fancy here. And okay, then calculate instruction height. Interesting. So let me just step over. Calculate instruction height. So yeah, let's step into it just to see what it's doing. let's just do real quickly. So it calls some kind of constructor for logging, not interesting. Okay, does the same thing. It seems like they're calling this millimeters to pixels for pretty much any dimension to account for DPI, which is, a smart way of programming. Get help button size. Let me see. I'm not sure which is the help button. It could be this one. Yeah, like this looks like a help button, so they get its size. Okay, get device context. Okay, this is the GPI++ stuff. Okay, they do GPI++ create device context. Okay, now what is this thing? Instruction text to parameters. Interesting. They're retrieving some text. Oh yeah, of course, yeah, they need to calculate something. They need to know the size of this stuff. Like for instance, when they display one of these messages, they need to know the size, or I'm assuming they need to know the height. So yeah, they are doing all this stuff manually. So let me go through this real quick. So they got some kind of text here. They probably have it localized. There's some, this stuff is basically floating point calculations. Looks really crazy in assembly. But down there, I saw, yeah, like this get measure string. This is a GDI++ function. So if we look it up in MSDN, and I think they bashed it all together. Yeah, so here you go. Basically, it measures the extent of a string for specified text, font, and so forth. So in our case, now what it's doing over here, if you see, its second parameter is the string. So let's see what kind of string are they passing into it. So RCX, RDX. If we switch to hex view, if I hit G and go RDX, oh yeah, this is the text they're passing. And by using the text, this is a very easy way to kind of locate where exactly, which control you're dealing with. So what they have is they select the snip mode using the mode button. And since we have it here, oh yeah, it's this thing over here. So in other words, it's, let me see, you can probably see it before I can actually draw in it. It's like this part, right? So the text is this stuff here. So what it tells me, they're calculating the layout of this little banner here. And what it also tells me is that we don't really want to mess with it. So let's just step out of it. And if we look at our call stack, where it calculate instruction height. Oh yeah, sure, yeah, it makes sense. So this little banner here is, they're calculating the height of this little thing here. And this is not what we want to mess with. So right now they're like deleting everything. All the handles and stuff for drawing. And I believe, oh yeah, it's probably returning H result. Oh yeah, and the return value is here as a pointer. Okay, but this is not what we need, because again, we don't really need to mess with this thing here. We want to know this part. So let's just keep scrolling. Again, let's have this get help button size. I'm assuming it's one of these buttons here, probably this one. Yeah, it's interesting how they do all this stuff manually. And okay, then they have this function, calculate sketch banner height. Oh yeah, guys, that might be this thing. Let me save this whole line, because that seems to be what we actually need to patch here. Because you know, if we know the height of this thing, we can technically change it here. So let me step into it and kind of quickly see what it's doing, kind of like really quickly go through prologue here. And it seems like they're calling logging function. Again, they do some conversion. Again, this millimeter to pixel function. Now what is this thing? Get sketch banner toggle size. Okay. Not sure what that is, some kind of toggle. Oh, maybe, oh, okay, maybe it's this button here. Okay, just a guess. Okay. Oh, they're changing something. Okay, interesting. Getting device context. Probably we'll be using it for calculation. Let's see, what is this thing? Ooh, okay, they're using C++. Okay, this thing is not very interesting. Seems like they're just like copying or doing some math. Okay, measure text size. Another measure text size. Is that where they measure actual size of this thing? Show window, invalidate rectangle. Interesting. Yeah, that's a really long function. Let me see, what are they measuring here? So, text size. I'm assuming, just looking at the declaration of this function. So the first one, they pass a shared pointer. In this one, RDX looks like the actual string. Let me try. If I go RDX. I'm not sure what this is. Okay. Let's keep going. Yeah, the string, it's probably some kind of Unicode character here. Let's see, what is this sucker? Okay, another measure text size. I think the same function. Let's try to see what's in RDX or in its second parameter. Interesting. Am I reading it correctly? Is it R8? Oh yeah, it is probably R8. Yeah, it's okay. It's probably IDA. Let me see. Oh yeah, of course, it's a class function. So RCX would be this, RDX would be this parameter, and R8 would be the string. Okay, well, didn't calculate correctly, but this is the string. In a future update, Snipping Tool will be moving to, yeah, guys, this is, yeah, here we go. We are in the right location. So basically that string is this thing here. In the future update, Snipping Tool will be moving, blah, blah, blah. So yeah, this text here is exactly what they're measuring. So let me step over and let's see, try scratch the button size. So they calculate some kind of button in there. Then they show it. Oh, interesting. Oh yeah, and then they move evidently something in there. So yeah, they're pretty much setting up on the fly and then redrawing all of this stuff here. And so yeah, I think we're kind of like leaving. Let me see what this thing, they're using control flow guard here. It's kind of like a security feature, but basically it kind of obscures the actual function. Oh, that's for GPI++. Yeah, reference counting, not really interesting. And yeah, so now they're cleaning up, deleting everything. That's the destructor for the logging function. Okay, and RAX, yeah, it seems like the return value is hResult. And on the input, they have two parameters. One is the long, and the second one is long pointer. Something tells me that this is probably the width, and this is probably the receives the height. So yeah, like this thing here. Okay, RCX becomes this, and this is the height, and this is what gets the height of the toolbar. This would be my guess, because it doesn't do anything else. It does a few calculations. Yeah, adjusts it from DPI for DPI. And yeah, pretty much, yeah, it does additional stuff here, redrawing, yeah, and then it changes the location, the position of the actual window. Okay, guys, this is very, very promising. Okay, well, guys, I'm not sure if you were following, but let me recap real quick. So this function, just copy and paste and kind of write it in a little bit better view. It's return an hResult, which meaning if it's 0, it's success. And what it seems like it's doing is that it's passing width as a long parameter, but then it kind of receives height of this sketch banner, as they call it. So to verify that this is what is happening indeed, we need to try these two parameters and see if my theory is kind of correct. So what I will do, I will put a breakpoint over here and run it. And when I hit this breakpoint, let me see. So R8 is some location in memory. So let me do right here and switch to R8. And as you can see, R8 is 664. So it's this highlighted, basically highlighted area, these 4 bytes. And EDX is 2CB. Now, if you look at my width of the window, remember like what I did with the actual window when I just measured it with the notepad, with the paint. As you can see, 2CE is very, very close to 2CB. So this tells me that the actual width of the window is 2CB. And this is what they're passing. Again, the second parameter in EDX, again, if you remember the calling convention. So second parameter is EDX, which is lower part of RDX. So they're passing width. And on the output, they're trying to receive the height. So the height is at this highlighted area here. So let me see if it changes when I step over the function. So again, right now, watch that location. And sure enough, we got 13B. So let's write it down. Possible banner height. Let's see, what was it? And what I'm doing, I'm just reading these, and it's 13B. And 13B. If we convert from hex 13B into decimal, it becomes 315. So this is a possible height of the banner that, you know, we kind of need to hide. And if we go back to our paint, so let's try to select the sucker and see if this is indeed close. And it is. You see, like over here at the bottom, it says 48 by 318. Well, I was close when I was selecting, but this is the actual height of this banner. So what we can do, just to prove our point, if we set this, let's say edit to 0, and then we apply and run it. Okay, well, unfortunately comes back, so I have to do it again. So in this case I need to go to R8 and step over, and again go to edit. Probably click too many windows, so let me just start over again. Hopefully it will work. Okay, so let me remove, and voila. As you can see over here is a snipping tool without the bottom banner, and this is the snipping tool with it. And this is exactly what we wanted by hiding it here. Okay, well, that was a really long one, so the only thing that's left is to actually find a way to patch it. Now what I usually do, I usually look into the function that kind of like does all the calculations, and then I check, is there something in it that, you know, if I remove it, basically, would it break the flow of the program? So let's step through it real quick. I'm stepping into it. I've done this before, but let me do it again. So it seems like this one is just a constructor for the logging function. This one converts pixels to millimeters, as the name suggests, or millimeters to pixels, basically account for DPI. This thing, I believe it gets the size of a button. Probably, let's see, what is it? Probably this button, but again, doesn't really matter for us, just gets the size. What I'm looking for is something that doesn't affect the flow of the program. Technically, if they programmed it right, it shouldn't. Okay, this changes control, I believe, inside, gets device context. This one is just creates a shared C++ pointer. Okay, this one I believe is just some calculations, or maybe moving of memory. Nothing really interesting. Okay, this is measuring text size, you know, for the text that they will be displaying. All this code, I believe, is just, it comes with C++ because of, like, you know, all the copying and stuff that they need to do. And this one, get try sketch button size again. They're doing it twice for some reason. Then they're showing all the controls, I'm assuming. Now show window is kind of like tricky to know which exactly it's called for. Let's see, sent window position. It seems like they're changing something inside of that control. Invalidate rectangle, just basically to redraw it. Okay, these control flow guard calls are coming from, I believe, let me just step into it. They're coming, yeah, so it's GDI++ stuff. Really nothing interesting for us. It's just basically destructors and deleting DC. Just removing and cleaning up the logger. Yeah, guys, in my view, this function is not really interesting or necessary. Let me see if it's used anywhere. I'm going to list cross-references, and yeah, it's not even used anywhere. It's just literally used here once. And this tells me that we can eliminate this function. So let's see, how can we do this? So we basically have, let's say, something like this, right? So, and this gives us a result. Just move this out of the way here so you can see a little bit better. So what we're trying to do, like in real function, I would assuming that it would do if result, I think, succeeded, like this, and then it would do the work, right? Let me just double check. I'm assuming it's checking. Yeah, you see, like over here, this function, it's basically, I mean, not function, that instructions, test and jump signed, it's basically checking for succeeded. and succeeded, it's this, more than basically if result is greater or equal than 0. So that's what this does. And yeah, so if it fails, yeah, it just goes here to the end and doesn't do anything. But in our case, so what we need to do, instead of this stuff, we need to set this to 0 and also height to 0. So obviously we set height to 0 so that we, you know, hide this thing at the bottom, or, you know, hide this part at the bottom. But we also need to make sure that we set the result to 0 so that this if statement works. Well, this is kind of easy to do, to be honest with you. So let's look at the machine code, as I always do. And we go to General, and we set number of opcodes to 8 so that we can see. And so what we need to change, okay, we definitely need to change this instruction, you know, the call itself. So let's just do it here in our notepad. Let me just remove all this junk here to make it a little bit more readable for you. So the call to this function definitely has to go, so we have to replace it. But what we also need to do, we need to set, instead of setting this instruction, right, so we need to write, because, you know, over here what it does, it sets R8 the address of the this thing, but we don't need to set it. We need to specifically set it to 0. So let me kind of grab all 3 of these things, and instead of this one instruction, we need to change all 3. So this will be our original stuff. So let me just format it a little bit better so you guys can read. So load effective address into R8 and then move EDX. Again, this is EDX, our value of int. And the important part for us is to keep this, just keep this RCX, because we need to set RCX to our this pointer, because, you know, this is what enables the C++ stuff to work. So okay, this is the original stuff, and let's think how we can actually modify it. You know, guys, I kind of looked at it, and I paused the video and kind of looked at this function. To be honest with you, I don't think I want to totally remove it, because it's doing something internally. It's calling show window and invalidation of something, so it might be connected to some other drawing, which I don't really want to remove. So let's take a slightly different approach. Now, if you look at my original C++ code, so what it's doing here, it's calling, it's doing its work, it's setting up the height, then checks the result and does whatever it needs to do. Instead of doing what I was suggesting here, what if we call it, but then instead of this, we set result to 0, and also, you know what, we don't even have to set result to 0, we just set the height to 0, and then just remove the jump. Because, you know, we don't really have to, because, you know, since, well, we're not doing anything, we always set the height to 0, and then we remove this jump here. I think that will be more logical. In other words, let it do whatever it needs to do, but in our case, we care only about the height, and we have to set it to 0. And then we remove this conditional jump, in other words, we always succeed. So I think this will be safer to do. It's kind of like on the second thought. And let's see if we can actually do this. So if we go back to the code, and so yes, so this line calls the function. So what we need to change would be this stuff here, right? So EAX and testing EAX. So yeah, we just basically set it to 0 and remove the jump, and also set this parameter to 0. Before we do this, let's see if the result of the function is actually used anywhere else. Yeah, it's writing into it. Oh, and it's reading from it. So yeah, guys, I'm not sure if this, offset, basically this local result is used anywhere. Just to be safe, I will also do this, because sometimes it might check this result further down the code if there is also like result something like this further down. So I don't want to just leave it hanging. So that is why I will set both to 0 and remove this jump. So I think we should be able to do it, because setting anything to 0 is really simple in assembly. So let me get back to my IP. So yeah, if we work with these 3 lines and copy them and kind of like show it in Notepad. So let me just clean it up real quick. Okay, so we are removing these and we are setting this. And yeah, you see like this instruction is really small, so we can set another one over here and then just add it with nulls. So the only thing I want to do, I want to convert from this madness into what it really is. It's really simple. If I take machine instructions like I did before, we'll go to disassembler, disassemble, and this is the actual instruction. Okay, so this is old, and let's come up with new code. Okay, so what we need to do, we need to call this, but instead of EAX, we need to set it to 0. What usually happens with compilers is that they keep one of the registers as 0. In this case, I'm just looking at because I'm still broken here on this breakpoint, like RBX is one of the registers that the compiler is required to keep, and it has value of 0. As you can see, they're actually using it here. Let me see, where did that RBX came from. So if we go all the way up, as you can see, they're always reading from it, but they're not setting anything into it. Okay, and this is pretty interesting. So you see, like right at the beginning of the DoLayout function, they're actually setting RBX to 0. Quite often, again, this is what happens with compilers. They dedicate one registry, one register to set to 0, and that's what they're doing by XORing it with itself, and then they use it later, because again, 0 is quite often used in many calculations. So in this case over here, because RBX will be always 0 in our function, we can actually use it for our purpose, right? So this is how we do this from our patch here. But what we need to do, we need to set this guy also to 0, and for that we need to find the actual offset. So what we're doing is that we're calling this, but we don't know where exactly that offset is located. So it's pretty easy to see that. As you can see over here, this instruction kind of gives off the location. So if we disassemble this here in the actual good disassembler and see what this thing is, so this is the actual offset. Let me just copy so that you can see in the notepad. Right, so our offset basically RBP minus 35, and that's what we need to do here to set our height to 0. And again, we're using EBX to set our height. And the reason we're using dword or 32-bit registry is because we are working with long. And if you remember in Microsoft Visual C or C++, long is 4 bytes. Okay, well, that's pretty much what we want. Let me just copy these things. So we need to get machine code for these two instructions. And we again use our trusty assembler in this case. And let's see if this becomes in machine code. Again, I'm trying to get it without my comments. Okay, and pretty much 2 instructions. Let me remove these. Okay, and like if you remember my usual binary patch situation, I usually combine all of these into one line so I can find it in the hex editor. So this is what we need to replace, and this is what we will be replacing it with. Also, if you remember, when we replace something with something smaller or larger, we can't expand or shrink our machine code. So what we need to do, we need to pad it. And in this case, I'm padding it with 90, and 90, if you remember, is a no operation. It's kind of like 90 hex. It basically tells CPU don't do anything, and that's really good for padding. And what we're doing here, replace with, right? So need to replace and replace with. So somewhat really simple binary patch, and at this point we can just go ahead and do it. Okay, so for that, let me close our debugging session, and also let me close this guy. Let me just clean it up so that you guys can see. Okay, this is our executable, so let's open it in hex editor. Now at this point, this is very, very simple step. You just need to find this binary sequence that you're replacing. Make sure that this is only one, that it's found only once. And when you find again, so it doesn't, doesn't happen. And technically you can do replace with. I'm usually more careful and do it manually, but you can technically do this kind of thing. Oh, what's it saying? Let's try again. Can't find it. Okay, well, guys, let me just do it manually. So what I usually do, just highlight it like so. It is important to actually put all these bytes correctly, because otherwise, if you make mistake, that will crash the program. So we go 89, 5D, C6, 7, 8, 9, 5D, CB. Let me make sure. So it was 80. Oh, come on. Come on, Windows, you're not helpful at all. Okay, so it was 88, 75, 02, 00. Okay, so we need to replace these with 90s, and that's 5 of them. Okay, let's double check. So 89, 5D, C7, 89, 5D, CB, 90, 1, 2, 3, 4, 5 times. Okay. This seems like our patch, so let's save it. And before we go any further, well, you can technically run it to see if it shows the result, but what I usually do, I check that I put everything correctly in IDA. So let me just start over. Oh. Did I not close it? Now let me close it. And again, so start over. And in this case, oh, it shows me that the binary has been changed. Okay, so we're in WinMain, creating window. And over here, we got into our DoLayout. So if we go quickly through it, if you remember that this is the code that we actually went through before. So pretty soon we should see our patch. Okay, so we get all these crazy buttons. Oh, wait a second. Let's see, IDA doesn't really see. I think it's trying to use the old. Yeah, guys, I don't know what's going on here with IDA, but basically because it didn't analyze this chunk, it's stumbling. I'm not sure if I can make it analyze right here. What I usually do, I usually open it as a new project. I just don't save and delete this one. So just open it from scratch because we technically have all the information to locate it. And just again load symbols. And I wait for the WinMain to be ready. Set a breakpoint, and all of our breakpoints should be gone by now, that we can easily recreate it. So yeah, if we look here, we have the actual function. So if we go into our module, we need to load symbols for it, and then we do Control F, locate our function, and this is the function, so we can put the breakpoint. Let's make sure that this is the one. Okay, so now we can just simply run when we get to it, and at this point, because IDA analyzed everything, so we should be able, it should be able to show us, you know, the correct code after a modification. This is just a bad disassembler. Maybe in the future I'll start using x64DBG so that we don't have to deal with this stuff, but this is basically what the problem was. Okay. Now what is happening? Did I just... Okay, guys, let me pay more attention. So something just didn't work. So in WinMain, then we get to our function. Is this indeed our function? doesn't look like this is our function. Okay guys, sorry for this. Let me just do it a little bit slowly. So we go here and we go here, copy it. Okay, is that... It doesn't look like it. There was no... Let me check the rest of them. Yeah, it looks like that is it. Okay, so logging, yeah, converting millimeters. Yeah, I'm just again trying to recreate the steps and make sure that we did the patch correctly. Okay, that's that button size, we got it. Okay. And then it kicks us out. I'm not sure if I'm in the correct spot. And then causes an exception. Well, let me see what is happening here. Okay, well, I have to pause the video to actually see what I was doing. I was putting a breakpoint on this when in reality it should not be the actual function. I was stepping through it, but I need to step out of it. So if we go back to our debugger, let's start over and get to our function, and that is this CalcScreenSketchBannerHeight. Step out of it, and then we are actually faced with our patch. So what we're doing here, as you can see, EBX is 0, so we are resetting resetting those two parameters as we kind of showed here with our patch, and then we continue doing its thing until, you know, we get to set window position, which I believe is somewhere in here at the very bottom. Yeah, like this one, when it actually resets the window. So in this case, we can see with the disassembler that our patch actually works, and again we removed that jump which was there originally. Did I save it? Yeah, like this one. And jump sign, that basically means if the value is less than 0, if it's negative. So in this case we eliminated it because, you know, in our case we always set that value over here to 0, so we don't really need to do anything with it. So at this point, let me start the app without IDA, and as you can see, we just eliminated the bottom part. So, and if you remember from the previous example, we can run many snips, so we're not limited by just one. And this pretty much what we kind of, you know, needed to do in this example. Okay guys, at this point I will finish part 2 of this very long second patch. As you can see, reverse engineering is a really slow process. It takes a long time. So at this point I will finish this part, and next time I will try to add additional changes, and see you then in part 3.